Welcome back to the virtual classroom of Cambridge School of Chemistry here. Right, seems like there's a delay in loading the tute to the screen, but I'm going to, since all of you have the hard copy of the tute, so I'm going to read from the tute and then explain. Right, so it might take some time, maybe due to the delay in the internet. So I'm going to start the nitrogen compounds chemistry. Compounds of the amines, study on the amines, amides, and the amino acids, and we'll be also studying about the proteins. So as for the amines, there are three categories of amines. Amines can be classified as primary, secondary, and tertiary amines. Classification of the amines: the primary amines, the NH2 group, is attached to one carbon containing group. I'm representing by R is the alkyl group, so this is primary amine, and there are two alkyl groups of the same kind or different type, that's referred to as secondary amine, and if there are three alkyl groups of the same kind or even different, that is referred to as tertiary amine. So amines are three types: primary, secondary, and tertiary. We'll be studying the chemistry of only primary amines, but you need to know how to make secondary and tertiary amines. So the synthesis of secondary and tertiary amines will be done, but the study will be only on the study of the chemistry of the primary amine. The difference between amines and the amines is that the amines, the NH2 group, is attached to a carbonyl group, whereas in primary amines or just amines, it's a NH2 group or NH group or N group is attached to the carbon containing group. So that's the difference between amides and amines. So amides, we have the carbonyl group, NH2 group attached to the carbonyl group. As for the amines, it is just NH2 group or NH group attached to the carbon containing group. As for manufacture of primary amines, secondary, and tertiary amines, you know the reactions we have done this for is any haloalkane react with ammonia, but this ammonia should be in ethanol, that's known as ethanolic ammonia, warm in a sealed vessel, no heating under reflux, right? No heating under reflux, because ammonia, ammonia will escape the reflux, the condenser, right? So when you do this, you get the amine, and ammonium chloride will be the byproduct, not HCl. HCl is produced, in fact, it reacts with ammonia to form ammonium chloride. So that's the byproduct. So this is primary amine. So ammonia has to be in ethanol because ammonia is a gas. It should be dissolved in the organic solvent ethanol, and you warm in a sealed vessel. You don't heat under reflux because reflux condenser will escape, the ammonia will escape the reflux condenser. So you should not heat, you should only warm. If you heat, it will explode because it's a sealed vessel. So heating should not be done, so it's tightly warming in a sealed vessel. So sealed vessel itself will act as a reflux condenser. So once you produce a primary amine, this primary amine can further react with more haloalkanes, and that will result in a secondary amine. And secondary amine can further react with haloalkane and result in a tertiary amine. So this is the primary amine. Once it is formed, you have to further add the haloalkane to it, excess haloalkane, and the primary turns secondary amine. Secondary amine will turn to the tertiary amine, right? So is that clear? We can copy this for the first one, the first question, copy the classification of the amine, and copy this for the second one, that's for the reactions of the amine. Right? Seems like there's a small issue with the loading of the tute. I don't know why. Okay, please copy this too. So question number two, how state of primary, secondary, and tertiary amines are prepared when ammonia is heated under reflux, under pressure. Under pressure, the presence of haloalkane, the hydrogen of ammonia will be replaced by alkyl groups, resulting in various amines. And examples, you can copy how three amines are produced. The HCl is actually what happens here in the first reaction is the HCl will react with the ammonia. So it will produce ammonium chloride. HCl will react with the ammonia to produce ammonium. So that's the reason why in the first step you will not get the ammonia produced. Clear? The third method of making the amines is that you take the nitriles and reduce using lithium tetrahydroaluminate. That's one of the ways to make the primary amines. You take a nitrile, which is cyanide, you add lithium tetrahydroaluminate. I think we discussed this on the carbonate compounds in AS, also in A2 especially. This is a strong reducing agent. Whenever lithium tetrahydroaluminate is used, it's a must that you use in anhydrous conditions. So you have to use in dry ether. The dry ether is a condition for this. So you get R, CH2, NH2. You get a primary amine. What happens is that across the carbon-carbon bond, you add two hydrogens to this carbon and two hydrogens to this nitrogen. So you add hydrogen to both the carbons and nitrogen, you get a primary amine. So that's one of the ways to make the second method of making a primary amine by reduction of the cyanide. Right, so you can copy the reaction for the next one. Question 3. Nitriles can be reduced in the presence of reducing agents such as lithium aluminium hydride in dry ether conditions to produce primary amines. Please copy the reaction. As for the homologous series of the amines up to 5 carbon atoms, just like any other homologous series, the first amine is methylamine. This is methylamine. You increase the carbon chain, you get the ethylamine, propylamine, and you got the butylamine, and continues pentylamine. Right, so we can name this for the next question. This is ethylamine. We are on question number 5 now. Question number 4, I'm sorry. Question number 4. Name the homologous series. Draw the molecules and name the homologous series. So you have propylamine, butylamine, and pentylamine. Okay, So that's I think there's a small delay in loading the tute onto the screen, so I'm sorry about that. This is the homologous series of molecules which has the same general formula, same functional group, and the adjacent molecules in the series will be differing by a CH2 group. So as for the physical characteristics of the amines, all the amines have like very unpleasant smell, the fish smell. It has fishy odor, and amines are soluble in water because it can form hydrogen bonds with the NH2 group and the hydrogen of water and oxygen of water. NH2 group can form the hydrogen bonds with water, as well as the H of the amine can bond with the oxygen of water, can form hydrogen bonds. So the primary amines are soluble in water, but the solubility will be decreased as you go down the homologous series, because as you go down the carbon chain length increases. This carbon chain length is a hydrophobic chain length. So you can see as you go down the homologous series, as the carbon chain length increases, it becomes hydrophobic, even though the head is hydrophilic. Head is water loving, hydrophilic, but the tail is hydrophobic. It doesn't like water. So therefore, as you go down, the solubility will decrease gradually. Right? Solubility will decrease because the solute solvent attractive forces which is formed is not so strong. So therefore, it will be less soluble. Because I hope you remember the solubility concept. Any covalent molecule, because we don't talk about lattice energy and the hybridization energy when it comes to solubility of covalent molecules. That's only for the ionic compounds. When it comes to covalent molecules, you have solute forces, you have solvent forces. So what happens when you put a solute into a solvent, if that solute to be soluble in the solvent, the solute solvent forces should be stronger. That means solute should leave the other solute molecules, and the solvent should leave the other solvent molecules and form new bond between solute and solvent. So the solute solvent forces, if it is stronger, then such solid will be soluble. So the solute solvent for attraction force which is formed should be stronger compared to the rest of the attractive forces, a substance to be soluble, right? So that's the reason why solubility decreases as you go down the homologous series. And generally the amines are having strong intermolecular hydrogen bonds, very strong intermolecular hydrogen bonds. But if you compare with the alkanes of the same number of carbon atoms, they have weak dispersion forces. So that's the reason why amines have high boiling and melting point, and also the amines, they are less volatile compared to the corresponding the hydrocarbons like alkanes, because they have very strong intermolecular hydrogen bonds. And that's the reason the amines, actually the intermolecular hydrogen bonds of amines are not so strong like the alcohols. Alcohols, of course, more stronger intermolecular hydrogen bonds, and but amines are weaker intermolecular hydrogen bonds. That's why amines are more volatile than alcohols. The volatility depends on the intermolecular attractions. The boiling point, the melting point, the volatility all depends on the intermolecular attraction. So amines can form intermolecular hydrogen bonds like this. This is how it can form hydrogen bonds, which makes the amines to be less, high boiling point, and it is less volatile compared to alcohol, because alcohol hydrogen bonds are much stronger than the amine hydrogen bonds. So please copy this on the next page. After the note, the last bullet point, they are less volatile than the corresponding alkane due to the presence of strong intermolecular hydrogen bonds between the molecules of amine, only weak dispersion forces between alkanes. However, amines are more volatile than the alcohol. In the given space, you can copy this. Right. So these all amines are basic because the reason is they are basic, they react with the acids. The reason why they are basic is that the presence of lone pair on the nitrogen. If you analyze all the amine groups, there's a lone pair on nitrogen, therefore that will increase the basicity. Now if you take a long chain amine, the long chain amines are more basic than the short chain amines. If you take, for example, methylamine, the lone pair electron density is less, but the ethylamine electron density is more. Propylamine is even more. Butyramine is even more, because as you go down the homologous series, it becomes more and more strong electron donating group. This is a weak electron donating group. As you go down the homologous series, it becomes a more stronger electron donating group. So we know the alkyl groups, as the number of carbon atoms increase, it becomes more and more stronger electron donating group. That's what makes it strong electron donating group. So that it makes it more basic. I think now it's uploaded. Yeah, at last. So that's the reason why as you go down the homologous series, it becomes more and more basic. Right, so down the homologous series, basicity will increase, because that depends on how greater the electron density on nitrogen. And all the amines react with acids to form salts, because they are basic, and they undergo nucleophilic substitution reaction, because nucleophiles, the amines like the nucleophiles, because the reason is amines are electron rich as a lone pair, so it will attack the nucleophiles. As for the reaction of primary amines with water, I think we have discussed all this on the unit 4. The primary amines, I'm going to just quickly go through these sections. So primary amines, they react with water. That's only the basic members, the lower members. As you go down the homologous series, the basicity will decrease, because as I explained before, the hydrophobic nature will increase. So primary amines react with water. What happens? It results in alkaline solutions. So what happens here is the primary amines takes H plus from water and forms NH3 plus, and there will be an ionic bond between NH3 plus and OH minus. It forms alkaline solution. So this is the reason why it's alkaline solution, because the OH minus ions are resultant. Therefore, that makes alkaline solution. So ethylamine is much stronger base than ammonia, because ethylamine has an electron donating ethyl group, so that will increase the electron density on nitrogen, which makes it more stronger base compared to the ammonia, even though all of them are weak bases, right? And if you analyze phenylamine is even less basic, because we know benzene ring is an electron withdrawing group, so the nitrogen, the lone pair, even less available on nitrogen, because the lone pair get delocalized with the pi ring of electrons in the benzene ring. So the most basic will be the aliphatic amines, the least basic will be the aromatic amines. The ammonia stands in between. So please copy these two. Please copy these two. As for the reactions with acids, because amines are basic, all amines, they react with acids. For example, if you react with HCl, it reacts reversibly to form the salt, right? And when you add the alkali, it favors the backward reaction. So the reaction is reversed if strong alkali is added. So this is the reaction with acid. Please copy the reaction. So reactions with acid chloride. Now these amines, the primary amines, react with acid chloride, and they produce N-substituted amines. So if I take, for example, ethylamine reacting with acid chloride, you can notice here this is the NH2 group, and this is the acid chloride group. We have done this for unit 4 as well. What happens, one of the hydrogens of the NH2 group goes off with the chlorine, resulting in a HCl molecule, and there will be an amide linkage formed like this. So this is addition followed by elimination reaction, which is in short known as condensation. This is HCl removed, and you get this molecule, C double bond O NH CH3. This molecule is known as N-substituted amide. It is an amide, but it is N-substituted amide. Why we call this as N-substituted amide?